All right, welcome back. You've probably been there, right? Staring at a super complex problem, thinking, how in the world do I even start to tell a computer what to do? Well, that's what we're digging into today. We're talking about the most critical step, the one that comes way before you even think about writing code. We're talking about algorithm design.
So let's just break it down to the most basic question. You've got this machine, right? It's a genius, but it's also super literal. It does exactly what you tell it, no more, no less. So how do you give it instructions for something complicated and be sure it gets it right every single time?
And the answer? It's actually kind of simple. You give it a plan. That's it. But, and this is a big but, it can't be just any old plan. It has to be super detailed, a perfect step-by-step guide with zero room for confusion. And that plan, that's an algorithm. Honestly, the best way to think about it is like a blueprint for a house. You'd never, ever start building a house without a detailed blueprint, right? Well, you should never start writing code without a solid algorithm. Same idea.
So, if we want to get a little more formal, algorithm design is just the fancy term for creating that step-by-step strategy. And here's the magic of it. It's all about the logic. It lets you figure out the puzzle before you start wrestling with all the picky rules and syntax of a programming language.
Yep, that procedure, that exact recipe the computer follows to the letter, that's your algorithm. It's the bridge that takes you from a fuzzy idea to a rock-solid set of instructions. Now, when it comes to making these plans, we've basically got two main ways to do it. We can write it all out, kind of like a recipe, using something called pseudocode. Or we can draw a picture of it, like a map, and that's called a flowchart. So you've got your text option and your visual option. Okay, let's tackle the first one, the written recipe. This is pseudocode. And honestly, a ton of developers love this method because it's so clear and flexible. So what is pseudocode? Think of it like a simplified, structured version of English that just lays out the logic. The real beauty here is that you get to focus only on the steps and the flow. You're not getting yelled at by the computer because you forgot a semicolon or a bracket. It's all logic, zero picky rules. Now, even though it's not a real programming language, pseudocode does have some common keywords to give it a bit of structure. You'll see things like input, output, if, else. And the great thing is, any programmer on the planet will know exactly what you mean. It helps keep the plan organized and super clear. All right, so what does this look like in practice? Check this out, a super simple plan for finding the area of a rectangle. See how clear that is? Step 1, begin. Then input the length, input the width, do the math, and finally, output the answer. It's a perfect little recipe that anyone can follow. Okay, on to our second tool, flowcharts. And if pseudocode was our written recipe, a flowchart is the visual map. It shows you the entire journey at a glance. Flowcharts are all about using simple, standard shapes and arrows to show you the logical flow. And they are amazing for a few things. First, you can see really complex stuff visually. Second, you can spot problems or bottlenecks way easier. And maybe most importantly, you can show it to anyone, techie or not, and they'll get it. The whole power of a flowchart is in its simple visual language. It's like a key on a map. Ovals mean start or end. Rectangles are for actions, do this. Parallelograms are for getting input or showing output. And then there's the big one, the diamond. That's where a decision happens. Okay, let's walk through a quick one. Let's say our program is going to ask a user a very important question. What is the best subject? And boom, here comes our diamond, the decision point. The program takes the user's answer and checks it. Does it equal computer science? This is a classic yes or no moment. And from here, the path is going to split in two. If the answer is yes, we follow the yes arrow down this path, and the program says, of course it is. But what if the answer is no? Well, then we follow the no path, and the program says, okay, try again. See that? In a split second, you can visually see the two possible outcomes of that single decision. Super powerful. All right, so we've got these two ways to make plans, these blueprints, pseudocode and flowcharts. But so what? What's the real point? Well, this next part is the payoff. This is where we see how the blueprint becomes the building. And this is why we do it. The entire point, the real power of making an algorithm is that it lets you turn that plan into actual working code. It's not just a suggestion, it's a direct guide for writing your program. Okay, take a look at this pseudocode here. The job is simple. Find the biggest of three numbers. And the logic is just crystal clear, right? Get three numbers,
then check. Is the first one the biggest? If not, okay, is the second one the biggest? If not that, well, then it has to be the third one. Simple, step by step. And now, look at this. This is the actual Python code that does that exact same thing. Do you see how it's almost a direct translation? The input steps from our plan become these input functions here. The if and else if logic, it's pretty much identical. The blueprint literally became the building. That's the power of planning.
So there you have it. That's the why and the how of algorithm design. It really all boils down to one thing. Make a clear plan before you start coding. And now you know you've got 2 fantastic tools in your toolbox to do it. All right, let's just do a quick recap. The number 1 rule, always plan before you code. Your algorithm is your step-by-step plan. You can use pseudocode if you like thinking in text, like a recipe. Or you can use a flowchart if you're more visual, like a map. And remember, that plan isn't just some boring homework you have to do first. It's the very thing that makes writing the final code so much easier and more logical. Okay, so now it's your turn. Let's get you thinking like a programmer. Forget about code, forget about syntax. How would you write down the steps for making a simple cup of tea? I mean, every single step. What are the inputs? What are the processes? Are there any decisions you have to make? If you can do that, you're already designing an algorithm. And that, right there, is the heart of it all.